Hello friends, welcome to my channel World of Physical Chemistry. From the lecture series of Chemical Kinetics, today we will discuss a very important and interesting topic from the Chemical Kinetics. The topic is molecularity of a reaction and order of reaction. First we will discuss what do you mean by the molecularity of a reaction. The molecularity of a reaction is defined as the number of molecules, atoms or ions which are participating in a chemical reaction. For example, if we have the general representation reactant A, it gives product. Here only one reactant is involved in such a reaction. In particular example, for the decomposition of hydrogen peroxide, only one molecule of H2O2 is involved. Similarly, for decomposition of oxalic acid, only one molecule of H2C2O4, that is oxalic acid, is involved. That is the chemical reactions in which only one number of molecule, atoms or ions is involved. Such a reaction is called as monomolecular reactions, and for such a reaction the molecularity is 1. Now let us consider another example. Here we have written the general representation, that is reactant A, it combined with reactant B, it gives the product B, or 2 reactant A, it gives product. In both general representation, 2 number of reactant molecules are involved. In particular example, hydrolysis of ethyl acetate, here 2 number of reactant molecules are involved, ethyl acetate and water, therefore molecularity is 2. Here in decomposition of hydrogen iodide, 2 moles of hydrogen iodides are involved in this reaction, therefore the reactions in which 2 number of atoms, molecules or ions are involved, such reactions are called as bimolecular reactions, and for such a reaction the molecularity is 2. Let us consider a general reaction in which 3 reactants, that is reactant A, B and C are involved, which gives the product. In particular example, in both the examples, 2 moles of nitric oxides are involved along with O2 and Cl2. That is, in both particular examples, 3 reactant molecules are involved. 2 for nitric oxide and 1 for oxygen, and here 2 for nitric oxide and 1 for Cl2. Therefore, in this reaction, total 3 number of reactant molecules are involved, and such reactions are called as stir-molecular reactions, and for such a reaction the molecularity is 3. When we are discussing the concept of molecularity of a reaction, dear friends, we have to remember some important points regarding the molecularity of reaction. The molecularity of a reaction is a theoretical concept. That is, if we write this general reaction, in all these 3 examples, we just observe how many number of reactant molecules are involved. Here we can say that it is 1, here molecularity 2, here molecularity is 3. It is theoretical. That is, just by looking the chemical reaction written here, we can count the number and we can say that the molecularity of reaction is first, second and third respectively. That is, the molecularity of reaction is a theoretical concept, not experimental. Molecularity of a reaction must be a whole number. It should be 1, 2, 3. And molecularity of a reaction never be 0 or fraction. Molecularity of reaction never be 0 or fraction. Now we will discuss what do you mean by the order of reaction. Dear friends, do not confused with the molecularity of a reaction and order of reaction. It is very simple to understand. If we carried out a chemical reaction, just by theoretical knowledge we are able to predict the molecularity of a reaction. But to know the order of reaction, we have to perform the experiment. For example, if you have written this general reaction in which 3 reactants are involved, which give the product, just by looking this chemical reaction we can say that the molecularity is equal to 3 for this chemical reaction. But to predict the order of reaction for this reaction, we have to perform the experiment, and from that experiment we have to know out of these three reactant molecules whose concentrations are changes, and that number we call as the order of reaction. The order of reaction is defined as the number of molecules, atoms or ions whose concentrations changes as a result of chemical reaction. Let us consider the simple elementary reactions to understand the concept of order of reaction. I have written the first reaction, reactant A, it gives product. For this reaction, if you perform the experiment, and from experiment we found out that for formation of this product the concentration of A is changes, and then from that experimental knowledge we are able to write the rate law for this reaction, and the rate is equal to K, that is the rate constant, and this formation of product depends on this concentration of A. So here in this case order of reaction is first order. Why? Because for the formation of this product the concentration of A is changes, and that change in concentration of A we determined experimentally. On the basis of that experimental knowledge we are able to write down this rate law. Similarly for this second reaction we can perform the experiment, and from the experimental knowledge we can set up the rate law as rate is equal to K into concentration of A into concentration of B. Then the order of reaction is here this concentration raised to power, that is the particular number of reactant A and B changes. Here 1 1 it changes, therefore 1 plus 1 it is second order. But if experimentally we find out that for this reaction rate is equal to K concentration of A raised to 0 into concentration of B raised to 1. So here order of reaction is 0 with respect to reactant A, that is throughout that chemical reaction there is no change in concentration of A, while there is an appreciable change is observed for reactant B. Therefore the order of reaction is first with respect to B, and the overall order of reaction is 0 plus 1, it is first order. In third example, from the experimental knowledge we are able to set up the rate law as rate is equal to K into, that is experiment is found that for the formation of product the concentration of all the three reactant molecules are changes, and here some power, that is 1 1, it is third order reaction. Let us consider one more general representation of a chemical reaction in which M and N are the stoichiometric coefficients of reactant A and B respectively. For such a reaction we can set up the rate law as the rate is equal to K into concentration of A power raised to M, that is this stoichiometric coefficient of A raised to here into concentration of B raised to N. Therefore for this reaction the order of reaction is the sum of powers of concentration raised in this rate law, that is M plus N. So we can define order of reaction also as the sum of the powers of concentration raised in the rate law. It is called as the order of reaction. As we earlier discussed, we have to remember that the order of reaction is an experimental determined value. That is, to know the order of reaction we have to perform the experiment. The order of reaction may be fractional value. For example, the decomposition of acetaldehyde. If you perform the experiment, it is found that the rate of this decomposition of acetaldehyde is equal to K into concentration of acetaldehyde power raised to 3/2. that is the fraction. You have to also remember that the order of reaction may be 0 also. That is, if the order of reaction is 0, what it means? It means that the reaction is independent of concentration of reactant. Dear friends, now we are going to discuss the differences between order and molecularity of a reaction. You have to remember one thing always. There is no correlation between the order and molecularity of a reaction. Now, how we can differentiate the molecularity from the order of reaction? Molecularity of a reaction is nothing but the number of molecules, atoms or ions taking part in a chemical reaction. Order of reaction is the number of molecules, atoms or ion whose concentrations are changes during the course of chemical reaction, or order of reaction is the sum of powers of concentrations raised in the rate law. Molecularity is a theoretical concept, while order of reaction is an experimentally determined value. Molecularity of a reaction is always a whole number, but order of reaction can have fractional value, as we earlier discussed. Molecularity of a reaction cannot have zero value, but experimentally it is found that order of reaction is a zero value for some particular reactions. Molecularity of reaction is invariant for a chemical reaction. Order of reaction can change with the change in temperature, pressure and concentration.